Hello everyone, my name is Sheikh Ayub Malik and I am from 2CSCD. Today I am going to give a seminar on the topic of normal forms in database management systems. My roll number is 21BQ015K6. So let me get started. Normal forms are used to eliminate or reduce redundancy in database tables. To achieve normalization, we use normal forms. So here are the most commonly used normal forms. 1NF, 2NF, 3NF, and boy chord normal form. Boys and chord normal form. 1NF is first one, first normal form. 2NF is second. 3NF is third normal form. There are also 4NF and 5NF. Let us see a brief description. 1NF. A relation is 1NF if it contains atomic value. A relation is 2NF if it is 1NF and all non-key attributes are fully functional dependent on primary key. 3NF. The relation will be in 3NF if it is 2NF and no transition dependency exists. 4NF. A relation will be in 4NF if it is in Boy's chord normal form and has no multi-value dependency. 5NF. A relation is in 5NF if it is in 4NF and not contains any joint dependency. A join should be lossless. Let me get started with the 1NF. So as I have said, a relation will be 1NF if it contains an atomic value. It states that attribute of a table cannot hold multiple values. It must hold only single valued attribute. If it holds multiple values, it will cause redundancy and hence no consistency. First normal form dissolves multi-valued attribute composite and their combinations. Let us take a relational table. A relation employee is not in 1NF because multi-valued attribute employee form. Here John has multiple values in the M form. What we do is decomposition of table into 1NF. So what we do is we create different rows so that it will be in 1NF. What we did here, you can see John and this particular entry and app is UP is made into one row and with this particular number has made into another row to decrease, I mean to make it into 1NF. The second one is table to be in 2NF, it must be in 1NF. It means no multi-valued attributes. In second normal form, all non-key attributes non are fully functional dependent on primary key. Let's assume a school state can store data of teachers in a in a school. The teacher can teach one subject. Teacher ID subject and teacher age. In the given table, non-prime attribute teacher age is dependent on teacher ID, which is a proper subset of candidate key. That's why it violates the rule of 2NF. So to convert the table into 2NF, we decompose it into two tables with so that teacher age is no more dependent on teacher ID. So we divide these two and not let them stay in the same table. So what we do is teacher ID and teacher age in one, teacher ID and subject in one. That's why, and now this particular table has no redundancy. The next one is 3NF, the third normal form. A relation will be in 3NF if it is in 2NF and not contain any transitive partial dependency. 3NF is used for reduce the data duplication. It is also used to achieve data integrity. If there is no transitive dependency for non-prime attributes, then the relation must be in 3NF. Here are the two conditions. If a relation is 3NF, it holds at least one of the following conditions for every non-trivial functional dependency x to y. X is a super key, y is a prime attributes. Here the given table, the super keys are emp id comma name, id comma name comma zip and so on. Candidate keys emp id. Here these dependent on mzip and zip dependent on emp id makes non-prime attributes transitive dependent on super key that violates the rule of 3NF. To make this table complies with 3NF, we have to break it into two different tables, emp id, emp name and zip in one. Zip state, city and district in one because these two are dependent on zip. So we hence divide the table into two. Now it is in 3NF. The next one is boys for normal form. It is the advanced version of 3NF that is called 3.5NF and it is stricter than 3NF. To be it is BCNF. It is in 3NF and for every functional dependence x to y x should be a super key. Here, let's take the example. Functional dependence empire nationality, department to department type. Not in BCNF because empire to empire depend on loan fees. To make this, we divide the table into different tables: empire nationality, department type, number of employees, and mapping table EID and E department. Now he so we divided into three tables there. It is now in BCNF. The next one is 4NF. So to be a table in 4NF, it should be in BCNF and has no multi-value functional dependency. For dependency A to B, for single value A, multiple values of B exist. The reaction will be a function multi-value dependency. What is multi-value dependency? The table is multi-value dependency. For single value of A, multiple value of B exist. Here, for single value of 21, there are multiple values of hobby. So what we do is we divided ID and course into one, course and hobby into one. Yeah, ID and course into one, ID and hobby into one. Now it is in 4NF. The next one is 5NF. 5NF. For this, the condition, the table should be in 4NF, not contain a joint dependency. And joining should be lossless. For this table, it is not in 5NF, uh, as it violates the rule of 5NF. So what we do is we divide the table into two, subject and lecturer, and semester and subject. And again, semester and lectures into three tables. Now it is in 5NF. So this is about all the normalizations 1NF, 2NF, 3NF, boys called normal form, 4NF and 5NF. This is all about the normal forms. Thank you.